Okay, we're going to look at this first sample problem. So we've got aluminum oxide, which is aluminum and oxygen as ions, and they form an ionic compound with the formula Al2O3. A lot of the times though we call this alumina, and it's actually the main source of aluminum, like when we refine it to isolate aluminum, so we can use it as foil or in all sorts of things for industry. So we actually take aluminum out of this compound to use it. Okay, and we can find this compound in a couple different minerals, okay? But I'm not worried about the aluminum there, the compound, and all in one. Instead, I actually am looking for a specific number of ions in this case. So I know I've got a number of moles of this compound, and I want to find the number of aluminum ions in that compound, okay? So we can actually, I think, I mean, this is super doable, and I'm going to go ahead and extend this to the way I wrote it here, but on the slides I just realized that it's the number of moles. Alright, we're going to actually, when I look here for the number, that's something that we're going to do a little bit later, okay, so in just a couple days, like when you get back from the weekend. So pretend I didn't say that. So we got a number of moles of aluminum ions, just to keep it simple for now, okay. So I know I've got 1.25 moles of Al2O3. And I want to find how many aluminum ions there are for every mole of this. So in 1 mole of Al2O3 should have a specific number of aluminum ions. Now, the aluminum ion, remember that 3 here on oxygen actually comes from the charge on aluminum, Al3+. Okay, it's in group 13, so that's where it gets its charge. So we actually have a certain number of aluminum 3+ ions, so a number of moles, we'll say that, for every mole of aluminum oxide. Okay, so the charge from aluminum is down by the 3, but that means that I need 3 oxygen ions, and remember this 2 tells me how many aluminums I need, but it's also the charge on oxygen. So this 2 here is still telling me the number of ions. So I'm going to have 2 Al3+ ions for every mole of alumina. Okay. Here my moles of alumina or aluminum oxide will cancel, and I'm left with moles of aluminum 3+ ions. Okay. So we got 1.25 times 2 should be 2.50. Okay, and that makes sense that for every one of these I should have twice the number of aluminum. Now, these aren't just atoms, these are ions, because remember this is an ionic compound, so they are charged particles. I could get to finding the number, like the actual number, and taking this moles and going straight to particles, but those multi-step problems are things that we'll do in class, okay, and we'll have other videos on that later. But go ahead and try it.